Hi, my name is Monica. Today I'm going to show you how to solve questions on projectile motion. First of all, you might ask, what is a projectile motion? Now let's imagine that we throw a ball into this basket. The angle in which the ball was thrown is at an angle to the horizontal. So an object that is projected into the air at an angle, the object will be performing a projectile motion, and the path or trajectory in which the particle or the ball is moving is a parabola. Now let's have a look at this parabolic motion, which is a projectile motion. Now you can see that there is a bit of symmetry involved in this projectile motion. Namely, the time that it goes up is the same as the time that it gets down. So time t to go up is equals to time t to come down. Now during this time, which is 2t, the ball also moves from left to right. So the time to go up and down, the total time, is the same as the time to go from left to right. There is a symmetry involved in a projectile motion aside from the time. Let's have a look at the other quantities that are symmetrical. Imagine that a football is kicked at an angle theta with the horizontal with a speed u. Now what we need to do is to look at the horizontal component of this velocity. This is the horizontal component. All you have to do is to resolve this force, or rather this initial velocity, into the horizontal direction, and you will get ux equals to u cosine theta. Similarly, you would also like to resolve this initial velocity into the vertical component, and you get u sine theta. Now, this initial velocity here at an angle theta is symmetrical to this velocity, which is the velocity that it hits the ground. It is with this magnitude, the same as the initial velocity magnitude, and it is also having the same angle as the angle theta of the initial velocity. So the symmetry is involving the velocities as well as the time. So we know that the horizontal velocity is ux. All you have to do is to take u cosine theta, and you can also see that because there is no acceleration in the horizontal direction, so there is no added force in the horizontal direction, the horizontal velocities stay the same. So this is the horizontal velocity, it stayed the same. So this is also the horizontal velocity just before it strikes the ground, it also stayed the same. Now, what about the vertical velocities? The initial vertical velocity is uy, having this magnitude, but please remember that in the vertical direction, there is an acceleration that is pulling the ball down. The acceleration is in this direction, is in the opposite direction in which the ball is traveling upwards. So in other words, what it means is that this initial velocity will tend to decrease. So as it goes to the next position here, this velocity will be less than this initial vertical velocity until it reaches the tippity top, and at this position down here, the vertical velocity becomes 0. Now when the ball goes down, you will see that then the ball will be coming down in the same direction in which the acceleration is pointing. In other words, the ball will be accelerating on its way down. So what we have down here is that now the velocity, if it is symmetrical on both sides, the magnitude will be the same. That means this magnitude of velocity will be the same as this velocity, but the direction of the velocity will be negative. However, as time elapses, this vertical velocity will start to increase because there is a pull of gravity that increases the velocity until it becomes a maximum vertical velocity, which has the same magnitude as the initial vertical velocity but in the opposite direction. The motion of the ball can be split up into two dimensions, namely the horizontal dimension with its associated kinematics equation and the vertical dimension with again the associated kinematics equation. So we can handle these sets of equations separately. The only thing that is the same is that the time taken to move horizontally will be the same as the time to move vertically. But please remember that when you talk about the velocity of the ball at any point in the path, we are talking about the resultant velocity, which is the resultant of the horizontal and the vertical velocity. These are the velocities that are indicated by the yellow arrowed signs. Now the next thing we want to think about is are there equations that can help us solve the problems? Like for example, you want to find the final horizontal velocity, the final vertical velocity, etc. Yeah, indeed we can use all these kinematics equation that we have already learned in the previous topic on kinematics. Let's look at the horizontal motion first. So these are the four equations, yeah, the final velocity, displacement, and this final equation, v squared equals to u squared plus 2ax, yeah. So all these, I think you are very familiar with it already, yeah. So just trying to remember what I said just now, we are saying that in the horizontal motion, there is no acceleration, yeah, it doesn't get faster and faster. So these equations will reduce to very simplified equations. Let's take the first equation of motion, v equals to u plus ax. Now we have got these subscripts down here to remind ourselves that these are the equations associated with the horizontal velocities or the horizontal dimension. Now since acceleration is 0, so this term will go to 0, and what we have down here will be the final horizontal velocity equals to the initial horizontal velocity. Now the next equation, which is this equation, we'll see what happens. So again, the acceleration is 0, so then we are going to strike off this term, and eventually what we have is that the final displacement, or the displacement at any time, is just the horizontal, uniform horizontal velocity multiplied by the time. Now the next equation, yeah, the third equation of motion, Sx equals to ux plus vx over 2 plus time, multiplied by time. So since the final horizontal velocity is the same as the initial horizontal velocity, I'm going to substitute Vx, yeah, I'm going to substitute this Vx with ux. So your Vx down here is substituted by ux. So eventually what you have will be the horizontal displacement is ux plus multiplied by time. Okay, so it's the same as this equation. So what's next? The next, the final equation of motion is v squared plus equals to u squared plus 2ax. So what you have down here is, again, you're going to strike off your final term because there is no acceleration. So what you have then will be vx equals to ux, which is the same as this one, yeah? So eventually, in the horizontal motion, there are two equations to remember. The first equation is that the final velocity must be the same as the initial velocity throughout the motion. And if you want to find the displacement at any time, all you have to do is to take the constant horizontal velocity multiplied by time. So that would be, equations needed for the horizontal component of the motion. Now let's see what happens in the vertical dimension. Yeah, the vertical motion. So you can see that the particle, after every interval of time, your distance, vertical distance increases. Yeah, from here to here it increases. So we can find this increment, yeah, using the equations of motions that we have, all these three. If you want the fourth one, you can also add the fourth one, but I think 3 would be sufficient. Now again, the subscripts are indicated. Yeah, you can see y, and y here. It's important to put the subscripts to remind ourselves that we are talking about the vertical dimension. So all these terms with a, they are non-zero, so we have to retain them in our calculations. Now, the next thing we want to look at is a an example which makes use of the horizontal and vertical component velocities. So this is a very typical example for projectile motion. The question reads, a stone is thrown from the top of a building upward at an angle 30 degrees to the horizontal with an initial speed of 20 meters per second. If the height of the building is 45 meters, how long will the stone be in flight? So let's give ourselves a little bit more space. All right, now here we go. Now we have got the 20 meters per second. The angle in which it's being tossed up is 30 degrees. So the first step that you have to take is to resolve this 20 meters per second into the horizontal component, which is the initial horizontal velocity, 20 cosine theta, 30 degrees. Now, the vertical component will be 20 sine 30 degrees. Yeah, so the first step is to resolve this initial velocity. The second step is to assign the direction in which you want to take it as positive. So traditionally, anything going to the right, I take it as positive. Anything going upwards, I'll also take it as positive. Of course, you can take it in the opposite direction as positive, but I would like to choose it as though it is just like a graph, you know, positive direction in the to the right here and positive upwards, yeah, just like drawing a graph, yeah. So but there's no hard and fast rule as long as you stick to it throughout the calculation. So let's have a look at it vertically. You want to look at the time in which the stone is in flight, so meaning the time taken for the stone to go through this whole path until it touches the ground here. So we would want to use this formula, s equals to ut plus half at squared. The reason is because I know the displacement, so it's displaced vertically downwards by 45 meters. So that's why I put negative. The reason why I put negative is that I'm displaced downwards in the opposite direction in which I have stated as positive. So that's why it is very crucial to put a negative sign. It is non-negotiable. You cannot say that I don't want to put a negative sign, because the answer would be totally different. Now, the initial velocity is vertical velocity is 20 sine 30 degrees. So this initial vertical velocity is pointing upwards in the same direction as I have assigned as positive. So it will be a positive initial vertical velocity. Over here, we have got a minus 9.81. The reason is that while the ball is going upwards, yeah, there is a downward acceleration. So since I assign upwards as positive, downwards will be negative. So that's why the negative sign is in front of the 9.81 meters per second square. So after calculation, you'll get the time approximately 4.2 seconds. The second part to this question is, what is the speed of the stone just before it strikes the ground? So you want to find the speed down here, how much it is just before it strikes the ground. So what you do have to remember is that you need the horizontal and the vertical speed, because at this position there is a horizontal speed and there's also a vertical speed. So horizontally over here, you will see that you will get 20 cosine 30 degrees. So that's the initial horizontal velocity, which is the final horizontal velocity here. Yeah, final horizontal velocity. So vertically, you will have v equals to u plus at. So this u is the initial vertical velocity, the acceleration again minus for the reason that I've given you in the previous slide, and the time you got was from part 1. So when you solve all these in, you'll get a minus 31.35 meters per second. Minus, the reason why you have minus is because the final vertical velocity is pointing downwards in the opposite direction in which I've taken as positive. So it's consistent with what it should be. So then what is the final velocity? To find the final velocity, which is the actual speed or the velocity of the stone just before it strikes the ground, you must vector sum, or you must add these two velocities, the horizontal and the vertical velocity vectorially. So using Pythagoras theorem, you'll be able to find out what is your final velocity. So using that, you got 36 meters per second. Yeah, so that's your final velocity. The third part of the question is, where does the stone strike the ground? So here we are. So we want to find out how far, from the base of the building to where it strikes the ground. That means how much, what is the length horizontally? So we are talking about in the horizontal dimension. So to find the horizontal displacement, so that means this Sx down here, you just have to find out the product of the horizontal velocity with the time that you have calculated in part 1. So when you put them all together, you get 73 meters. So that's the distance from the base of the building to where the stone strikes the ground. This horizontal distance, which sometimes we call the range, is 73 meters. Well, if you find this video useful, please visit my website at www.physicstutionspecialist.com to learn more about how to solve problems involving projectile motion and other school physics problems. Thank you for watching. Bye.